headset today because I'm testing out some sounds. I don't think I'll keep wearing half a headset, though. It's surprisingly uncomfortable. Also, I had a little bit of a run, so if I'm a little wheezy, I apologize. But we're online. I'll go tell the world, because the world wants to know. Streaming, game dev, gonna do space debris. And we'll go ahead and put that over here as well. No, a little bit of a bloop. It's been so long since I actually wore my headset while doing any of this stuff that I forgot that some things actually have sound effects already. I should probably get rid of them, because that's annoying. Elboetchi says, "Hey, yo, Craig." Hey, yo, Elboetchi. Welcome. You are the one and only viewer. Over the past couple of days, I spent a couple of hours getting things a little bit more interesting. And I found how I can display a crap ton of debris really, really easily, really, really fast, really, really interactively. Right now, I don't, however, have an example set up. I'll set one up later if we need one, but basically what I'm struggling with now is I want the debris to look good. And I don't have a limit on the number of debris pieces I can use. So I've been experimenting with adding in a lot of debris elements. For example, down here, I have all of these little pyramid-shaped pieces of debris that I can slot into the various corners to make it look like there's something going on there. But they're not quite the same as the interior, so I'm thinking about redoing them with a focus on that. But these are great. I also have a lot of debris here to try and rough up the edge. I'm not sure I like how that looks. We'll have to look into it. We got some debris up here in the form of floating window panes. Now, these are all just a couple of pieces each, 10 here, 10 there. But I did some test runs with 20,000 pieces, and it didn't noticeably slow down the machine any. So there's not really a maximum number of debris pieces. It's just a matter of how I want things to look. The key is that I have to reuse the same meshes. I can't change meshes a whole bunch, so I'm only going to have hopefully 5 or 6 debris edge meshes, and that should let me use them however much I want. But if I have 50 different debris edge meshes, this method won't work. Anyway, let's open up the debris page here. The window that I created isn't quite good enough, so let's do first things first. Let's edit the window. And we're going to just go ahead and make it so that it has a closed off element, just because it looks better when it's partially closed off. So we're going to go and just do exactly that. We'll extrude here and pull it out and forward like this. And then we'll begin sealing it up, just to create a nice closed set. That's going to require us to pull some of these out a little bit so they're not quite as ugly. And then we'll just begin to just set up the things that need to be set up, like here and here. Nope, those are both bad, so we'll do it the other way, which is here. Merge edge loops. We'll just get rid of this entirely. Face is gone. And then we will go ahead and extrude this up like so. And then we will repeat the process of fixing these so that they are how we want them to be. Oh, it looks like I accidentally screwed up. That's fine. Not a big deal. We'll just manually select everything, and then once again, bridge edge loops. And then lastly, we'll want to take this and this. Come on. Bridge edge loops. There we go. We've created a complete surface now. And what we're going to do is we're going to take the middle of this surface and extrude it out. And then we'll use that as our baseline for creating a nice fractured core for our window pane. The edges are probably more realistic. Dotbow stepped in. The edges are probably more realistic the way they were, but the thing is that they didn't look good, so it's more important for them to look good in this case. The only question is, does that leave faces in the middle? And it does. Okay, so we don't want faces in the middle. We may have to think of a better way to do that. Oh. If we select 2 faces at a time, we still get faces in the middle, but only a set. So if we handle it like that, that should be fine. We'll just go ahead and delete all of these interior faces. I think that's probably the easiest way to deal. Delete faces. Because then we can just close up the top and the bottom. Boom. And now we're going to want to repeat that on this side. So we'll just start to close up all these faces. Again, I think it's probably best if we delete all of these middle things, middle elements, just so that we don't have to worry about them. And then we will just start to seal things up. So if you want to seal things up, there are a couple of ways to do it. The way we're going to do it right now is we're going to start by sealing these ends. Then we're going to select this, hit Control F, and hit fill or grid fill, our choice. I think fill's probably better here. And same here. Closes it off without having to worry about Unity misinterpreting an end gun. But you can see that the setup does not properly have the materials the materials get screwed up. In addition, any UVs you have will get screwed up. So you'll need to be careful about that. And we'll just unwrap everything again. That'll make our windows look a little bit better. And we also need to make this more closely appear to be one of those elements from the rest of our design. So we're going to go ahead and clone it from another file. Just drag some stuff around here so that I have it at the right point in my taskbar. And grind, grind, grind. You'll see the windows have now popped into having a more completed look. And we'll go ahead and open up the small ship shells here, the large ship shells. And the things that we're duplicating are the these surface elements in here. Now we want the one that's intact, and I don't know whether or not I left any intact. Well, I guess we'll just take a look. So I believe that none of them are intact, are they? Is this one completely intact? Well, that one is named correctly, and it appears to be completely intact. I think that is the one that we will copy and base our systems off of. Just paste it right in. There it is. And what we're going to want to do is make a pyramid-shaped debris out of this. And that's not as hard as it sounds, because all we really have to do is chop it up and move it around a little bit until it's pyramid-shaped. So, as you can see, this is a repeating set of elements, and since they're not perfectly joined, we can just grab huge swaths, like, say, this, and just drag the whole thing out after hitting L, and that'll give us a bit of depth, see? So what we can do is we can simply stack this stuff up until it resembles a pyramid. Oh, it looks like it is, at least to some extent, joined up. So we might have to be a little bit more careful. If I hit Z, it doesn't work. Okay, so if I move this, you can see how it causes damage. So what we're going to actually do here is we are going to just move it like so, and then cut these faces. And then we'll move it into position. Like so. And that is more or less correct, but it's not quite shaped right. What we're going to need to do is cut it into more of a pyramid-y shape. There's a couple of ways of doing that. One is we can use a binary operator, but I haven't had much luck with Blender's binary operators. Another option is we can just say, oh, that's good enough. But we really do need a sloped surface. These floating boxes are getting on my nerves, so we're just going to delete them all. And we'll keep deleting them all until they're all deleted. There we are. So what I think I'm going to end up doing is just grabbing and cutting. I could be a lot more careful about it, but, you know, whatever, right? The big thing is that we're going to just take this, and I'm trying to get a slanted view, but I guess it's not going to work. So we will just go ahead and use spherical select. I can't remember the button for that. We could do box selects, but they're all screwed up. How about a lasso select? Sphere or lasso would all work. I just can't remember how to do them. Here's the box select. Ah, C. That makes sense. We'll just paint ourselves a... Hello? There we are. We'll just paint ourselves a nice slope. Like this, that. Oh, apparently right-clicking undoes. That's interesting. There we go. And if I hit delete verts, then what we get is a slope. See? Now you might think that that's too repetitious, but I think it'll be fine because we're just creating debris. Switch over into vert mode and delete some of these dangling pieces that nobody wants. Perfect. You get a couple more dangling pieces here and there. They should be okay, but we'll just clear some of them out, and you know, just because we can see them, right? There's lots though. Deleting like that leads to a lot of errant pieces. We could have hit Control L or something, but the problem with that is that it selects more than you would like. I don't know, doing this is going to take forever, so I'll probably just leave it as ragged for now because I need to make sure that it actually looks right. For example, there are some things that clearly don't look right. The back side of this was never intended to be seen. So while the front side doesn't look too bad, this back end has a whole bunch of unsealed boxes. Now the way I'm going to fix that is I'm actually just going to select this entire set of elements like this, and then we're going to just scale it -1. The problem with that is that it doesn't scale properly. As you can see, we end up with quite a slant, but that's okay. We can hit Control-Alt-Shift-S and just bring it around to point the other way. Or we can scale it inversely on the y-axis as well, and then move it into position. The problem with that approach is that now we have it cut the wrong way. See that? So that's why we're not going to do it that way. We're going to use the slide instead. There we are. And I believe that that has inverted literally all of our normals, so we'll just flip them. Blip. There we go. Perfect, right? Yeah, close enough. And we'll name that something like, for example, heavy debris chunk, or debris. I've been using a name like this, so we'll keep our names working. We'll wander back on over into Unity, and we will start to assign that heavy debris chunk into our objects here. Now the structural debris is set up as a prefab, so I can grab it and change it out from debris structural to debris heavy chunk, and it should change everything inside the ship like so. The problem is that the material is wrong and a couple of other things like that, so let's go ahead and set this up with a prox interior material like this. And then we also have these all set up in the wrong spot, as you can see. So we're going to go ahead and delete all but one, and then we will manually place them just to see how it looks, right? So here is the one in question. And if you look, even though it's based on the exact same stuff as these guys are, it doesn't look quite right. first off, it's the wrong size, and second off, it's not the right color. If we look at these, they're all prox interior, and as are we. Let's go ahead and hit revert. Yeah. So why doesn't it look the same? I think it's mostly the angles involved. So if we were to just bring this down into the same area and point it in the same direction, it would probably look the same, I would hope. All right, so there. That is more or less the same, and you can see it does not really look the same at all. Why is it so much brighter? That is interesting. Is it because I've got shadow casting turned off? I think shadow casting's turned off here too. No, those are on. Okay, so that's the difference. This doesn't have any shadow casting, so it's not. Yep, there it is. There's the look I love. Okay. So then we can bring this down until it's about the same size as the rest, which is about like that. And you can see that now it blends in quite well. And we can just set this up to hide these nasty edges that we've got. So we'll do it manually. We could do it automatically if we had a good algorithm for it, but I don't have one in mind, and it would take a while to figure one out. So we will just do it manually for now. Yoink. Oh. Lots of fiddly little work for the outermost piece, just because it's the most obvious one. There we are, something like that, I guess. But you can see how immediately this starts to hide the edge that we have created. So if we were to continue down the line, we could continue to do this. The problem is that each of these counts as a shadow caster, and that's not great. We need the self-shadowing effect, just because that's what gives it its iconic look. If we change it so that it's not a shadow caster, then we just get this nasty-ass flat look, and that's no good. But shadow casters are actually very expensive. They're basically the one expensive thing left. So I don't know whether or not we can really do that. I might have to think of a better solution, but we'll think about it some more. If you got a great solution about shadow casters, you can let me know. Elboetchi says this is starting to look quite good. You have seen nothing, Elboetchi. I haven't even gotten started on how to make this shit look good. For example, I posted to my Twitter some serious examples of what this new system can do. Let me go ahead and show you. We'll just go ahead and create a new system just to demonstrate this setup that I've got. So what we'll do is we'll drop in a physics. No, we don't need the physics. We need the graphics. Simple strip. Simple help. There it is. Here is the debris quick spawner. We're going to go ahead and pick a piece of debris. I think the windows will look nice. So we'll grab that debris window pane here, drop it in here, and we will just go ahead and spawn 5,000 of them. I'll hit play. And now you can see that we are surrounded by 5,000 of these. Take a look at our frame rate. 73 frames per second. Yeah. I can use as much debris as I want. It's just a matter of making it look right. And that is actually quite a challenge. So, you know, we'll have to figure that out. I guess what we'll do is we'll just cruise on down there with this ship. And I should note that the debris, that window debris, that's not like a quad with a texture on it. That's a full-scale mesh with 2 materials and, you know, 100 or so verts. In fact, you can see it here. In fact, that whole field that I set up, that whole field was interactive because you can do this. Every single one of those things that I showed you, all 5,000 of them, can be bumped and pushed aside. So it's going to be pretty cool once I actually get everything working. Oh no, bonk. Come on, move your ass. Here we are. But this sort of debris is just, it's already so much better than it was last week, don't you think? However, it looks like my ship has some problems with certain kinds of colliders. We do need to add colliders to our structural elements here. So we're going to go over here into the structural debris, and we're going to add in a mesh collider. We need a mesh collider because otherwise we'll be able to float through these, and that would be really obnoxious. We'll make it convex just because that's nice and cheap. I can't tell whether or not that click worked. No, it worked. It's just waiting here. Oh, we are. Because I believe that we'll have a very expensive time of it if it's not convex. Another thing we can do is, because these are all structural, we can set them up as static. This is a good cheat, but I'm not sure if it's actually going to help us any at the moment, because the static batching is so much worse than the mesh instance batching that I'm using. So I'm not actually, I think that if we staticed it, it would be worthless. The only thing that would be good out of that is that if it was static batched, we could use static shadows. The problem with that is that the player's light is going to be a major part. Albuechi really likes the engine's afterglow, and I have to admit, I really like it too. It looks so good, doesn't it? The hope here, as I'm building this stuff, is that everything I'm doing will eventually look really nice. Obviously, I've only been showing you placeholder here, programmer art here, programmer art there. It's like, yeah, great, he's building this ugly-ass game. I guess it could be nice. But that's not the point. The point is to have a really, really pretty game. I know I won't be able to live up to any of the multi-million-dollar games out there, but I can certainly do better than programmer art. And we're just starting to get to the phase where that's becoming a bit of a priority. Now the question is, do I want there to be any debris in this area? Because I can put debris in this area. Let's go ahead and try it. Let's just put some debris in there and see how it looks. I have this debris game object tester here. We'll go ahead and call this a debris filler. And we'll move it over into this area. Whoop, whoop, whoop. And did I go too low? A little too low. Not a big deal. Just move it up some. There we are. Now, there are a couple of different kinds of automatic debris filling that I'm using. And one of them is just a spherical volume fill. Another one is a surface mount. And I'll probably have to use a combination of the two, I suppose. But either way, we're going to want to use a different debris element. This debris object is a better choice just because of the window not making any sense as an interior object, right? So this is the debris object. It's just a random piece of busted metal. We're going to go ahead and try it on for size. Albuechi says that there should be lots of debris in that area and that it should be like furniture and stuff. Yep, I like that idea. The real issue here is that I have to keep it to just 1 or 2 meshes because this method of using GPU mesh instancing is really fantastic, but it means that I can't have very many meshes, not if I want to instance them on the GPU. So that's the big constraint of this operation. Oh, I forgot to turn it on. It's like, where is it? I turned it off, and then I forgot to turn it back on. Brilliant. I don't think we need 5,000. I think 1,000 will be fine for a small space like this. But you're right. Right now I've been designing debris mostly as things that could convincingly be like hull damage. For interior damage, it makes more sense for them to be things like splintered interior walls and cut up furniture and stuff. And that would be a lot cooler to see as well, because you'd be moving from one kind of debris into another. But here it is, this is how I can fill the interiors. You can see that we're still running at 75 frames a second. And we can push this stuff aside as we move through the area. The sound is temporary. How loud is that to you guys? To me, it's quite quiet. But I may have adjusted my sound independently of what it actually sounds like. Let me go ahead and just take a look at OBS and see how loud that shows up as... Oh, that's not too loud at all. That's, in fact, it's probably too quiet. And in case you're wondering, that collision is faked, and it's my first take, so it's a little bit goofy. But because the collision is faked, there are no colliders involved in any of that. There's no physics computations, and that's why it is so damn fast, even though we are checking for literally 1,000 collisions a frame. I can also do it with particle systems. So I can make all of these into particle systems if I prefer. It would still work fine. Particle systems are nice because they don't have a game object per mesh. But they're bad because they have a maximum vertex count of 500,000 verts. And that means that I have to be a little bit careful about how many of these I summon in. Because I just summoned in, 1,000 of these, and that means that if each of these has, 1,000 verts, I'm already pushing the limit of what a particle system can do. I guess it's not that big of a deal. Now that I'm thinking about it, because if I'm operating at 1,000 of these, it's not that bad. But let's say I were to take it up to 10,000, then I would have to actually consider whether or not I was overloading the particle effect. Okay, so let me just tab over here so I can see what's going on. Yeah, and we're still running at pretty close to 70 frames. Okay, so now we're starting to drop down below 60 because I put in 10,000 objects just for kicks. You do not need 10,000 objects. I just wanted to see how it would look, and we're done at 50 frames a second, which isn't great because of the fact that I have a pretty good computer. But look at how dense this field is. It's almost worth it just to have something so ridiculously dense. And look, that's a real hole. We pushed through. It actually exists. Oh, bonk! Just the fact that this can still be rendered so easily is amazing to me. That was interesting. Oh, I must have paused. I turned off the mouse recapture. That's fine. We'll deal with that later. That's definitely not a very good sound for things clonking off your hull, but it works. This system works. I guess I should model some debris that works for interiors. Let's go back over to our debris file. We'll close this one. We don't need it anymore. And we'll move this aside and move this. Doesn't need to exist. Kaboom. And we will add in a piece of debris or two that could work for an interior piece of debris. And what I think I'm going to do is I'm going to build like a wall fragment and like a desk fragment, something that could be mistaken as either one. So we'll start with a cube, and then we will zoom into the cube so that our camera is in the right space. And we'll just quickly mock up something that looks kind of desk-like this, for example. And then we will modify it into something that could be mistaken for a wall and so on. So if we're going to go for something desk-like, I want it to be quite thin, but we also are going to want to have it be have some element of thickness to it, where there might be drawers or something, so like this, right? And then what we can do is we can actually plug in a drawer, just lock that in more or less correctly. We can actually create a drawer section here. So we'll split this in half and we'll create two drawers, right? So we'll extrude scale 0.9 and extrude scale 0.9. Now these are a little bit tall, so we'll drag them up a little bit. There we are. And one of these drawers will extrude out, and the other one will be missing, so we'll extrude it in. The question is, do we want it to do it like this or the other way? Well, we can always reverse it later if we have to. So if we extrude it out, then what we're going to want to do is extrude here, scale it down, but push it back, and then scale it down again, and scale that in. There we have a drawer that has come out of the desk. Now, we could make this drawer kind of akimbo. We don't have to have it come out straight. So, for example, if we grab this and then deselect the edges that are actually attached, we can rotate on the z-axis a little bit and then move it around until it feels kind of right. And kind of right is all you need in a situation like this. There, kind of right. Now let's add in some leg elements over here. And the way we'll do that is we will just go ahead and make them, I think that it would be good to have something a bit round. So we'll go ahead and add in a circle. Then we can make it like a 16 or 12. 12 is good. Yoink. And then move it into position. Can you zoom in on what I tell you to zoom in on? Jesus. Thank you. Jeez. If you've accidentally got faces selected and there are no faces, if you've got random things selected, like say 100 verts, but there are no faces involved and you're in face mode, Blender just goes and ignores you all the time. It's super obnoxious. They should realize that I may be in face mode, but if I have no faces selected, it should just work on whatever the selection I have selected is. Seriously, right? So we'll just go ahead and bend that like so. And create ourselves a nice bevel here to minimize the sharpness. And then down here what we'll do is we will extrude it a touch, and then we will split it with a subdivide that has a high fractal count. Like that. And what we'll do is we'll put it into this mode, and I'll want to make it so that it's a little bit, I think that's just a bad roll. Yeah, there we are. We got different rolls. Yeah, that's a good one. And then we'll Alt F, perfect. And then what we'll want to do is repeat the process with another one on the other side of this, like here. But obviously we don't want the same final touch here. We'll just grab it like so and extrude it in a different pattern. Bevel, and then again, we're going to want to do that subdivide. And once again, we got a bad random number. Yeah, that's good. Perfect. All right. So this whole thing is one material at the moment, but I don't want it to be. We'll go in here and add two materials. One will be our hull, and one will be our interior. And the reason for that is because that way we can have it have a couple of different elements to it, and that'll be nice. So we'll just grab here and here and here, make these interior, and then we will also, we have to make either the top or the bottom interior. I think the bottom is a better choice. And as for these guys, we'll make this part interior, but the rest will be hull. That's probably okay. All right, we will call this a busted desk A. And then what we're going to want to do is we're going to actually want to bust up this busted desk considerably more because it's not quite rough enough for our needs. So we're going to select this surface here and this set here, and we're going to subdivide them with some fractal. Not that much fractal, I think. Less fractal, please. We can also do a smoothness. Ooh, that smoothness is terrible. No smoothness then. What we're trying to do is just create some nasty roughness. but it might be something that I have to do manually. Let's go ahead and subdivide here with more cuts. There we are. It looks like it's going to have to be manual because that's not working at all. So we'll just drag this off for a second so that we can cut it freely without interference. And then we will go ahead and do a cut with Z turned on, and that will create a nice pattern like that. See? So now what we've done is we've created a new mesh loop right through the center here. And what we're going to want to do is bevel that and then create a proper dent, like so. That's probably fine. Drop that whole element back into place. Now we could dent the rest of this. I guess it's probably not necessary. We'll just go ahead and leave it like that. We could rough up the edges. Let's go ahead and see how this looks. I might have to make it triangular, or at least not so rectangular. We'll have to see how that actually looks. So we're going to go over here. This is the debris window pane. We're going to switch it out and make it into a debris furniture. And then we're going to start to switch out the elements. What I didn't name it correctly, did I? Debris. Busted desk A. And then this is the backup. I don't see a debris busted. Oh, it's loading. Why isn't it loading up? Save. Come on, give me some busted debris window pane stuff. Wow, there's something screwy going on here. Why isn't it letting me click on anything? A radar marker? I shouldn't be able to click on those. Come on! What the hell? That was really bizarre. Anyway, we don't need this box glider. And what we want is the debris busted desk A. I don't know why that took so long. There, we've got it. You can see that it floats above the 0 point. We're going to want to go and actually fix that because that is not good for collision detection purposes because I'm using the center as the main collider. So just move it into place. There we go. We got a Prox hull and a Prox debris glass. We're going to switch out the Prox debris glass for a Prox interior. There are reasons why that might not be great, and we might have to switch out that material later, but that should be okay. For now, at least. So, you can see the Prox interior is actually not a different color, which is one of the reasons that it might not be a good idea. Either way, we're going to drop this furniture into our prefabs as a new object. And then over here in our debris filler, we're going to drop in that furniture as the thing it's going to spawn. I'm going to drop it down to 1500 and give it a radius of 200. And let's go take a look at how that looks. Now, first off, it's not nearly as slow as spawning in 10,000 things. To be honest, it's a much lower poly mesh than these windows, so it might be just the savings of not having as many verts as well. It looks like this might be too small. These pieces of debris are tiny. Look at this. They're microscopic. I think that's probably a little too small. Let's go ahead and change the scaling on our furniture so that it's a little bit larger than that. Where is the apply? Isn't there normally an apply here? Oh, I did it as I did it in the prefab. Never mind. All right, let's go take a look at that debris. Now that I've scaled it up some, we can actually see it from this distance, and it gives us a little bit of a sense that there's something down there. So when I go into this area, you can see that it's now full of debris. Now the problem is that this debris is basically uniform, and that's a little bit tough to stomach. Just visually speaking, it's not a very great way to do it. Also, I have got to add some colliders to those surfaces, because that is, I keep floating through them and I need to bounce off of them. So we'll just go ahead and select these interior surfaces, all of these long placeholders, add a mesh collider to each, and turn all of them on to convex. Alboichi says desks should be quite a bit smaller than a spaceship. These are supposed to be pretty small spaceships is the thing. We'll see. It also gets harder to actually see the individual meshes, which helps obfuscate the fact that they're all the same. Well, they aren't all going to be the same. In the end, I'm probably going to use a couple of different meshes. Either way, I don't like how this collider worked, so we're going to go ahead and hit inflate and see whether we can reduce that count, because that is an atrocious count. Grind, grind, grind. That's much better. All right, thank you. So with that in mind, we're going to change the code of the spawner to allow us to weight it slightly differently. Right now, we are spawning in a sphere. There are two basic options as to how we can change that. One is we can change it so that it's not a sphere, and the other is that we can weight the sphere so that it isn't actually fully random. And the way we're going to do that is we're going to actually square this unit inside sphere, or maybe square root it. I think square root is maybe better. Problem is it's a little bit slow, but whatever. Oh, I can't. It's a random inside unit sphere, isn't it? So I can't really square root it, because you can't really square root a vector 3, can you? No. So I guess I'll have to do it a slightly different way. So vector 3 pos equals this. And then we will go ahead and say that pos equals vector 3 dot pos equals pos plus pos dot normalized divided by 2. And that way it'll push it towards the outer edge of this sphere. It'll also be cheaper than taking a square root, but I'm not really concerned about that. It's also going to mean that there's actually going to be a hole in the center rather than a nice debris field, so maybe that's not a good call. Well, we'll see. Bunch of teeny tiny little... Yeah, so you can see as we break through into the inside of the sphere, and there's really nothing there. I do need to do it as a square root. Come on, behave. For some reason, I decided that I wanted to print shit. I don't want to print shit. So what we're going to do is we're going to take a pause. How can we do this? We can do a vector3.lerp between pos and pos.normalized, with a magnitude being the square root of pos.magnitude, right? So if we do that, then what we'll end up with is, if the magnitude is 0.1, then we'll end up getting the square root of 0.1, which is a larger number than 0.1. It'll push it towards the normalized value more. Yeah, that'll work. Now, the reason I want it to be this instead of squaring is because if it's squared, all of the debris clusters towards the middle, which doesn't really make any sense because what's supposed to happen is it's supposed to cluster towards the edges. That's the point. So the other thing we can do is we can do raycasts out and try and collide with edges and do that way, kind of a saturation thing. I actually already have a system for doing that, but it's not perfectly suited for this kind of debris, so I'd have to reprogram it a little bit. I want to see if I can get away with just making it spherical, just because it's cheaper and it can be done at runtime. I think these are still too small, but they are also very obvious. I'm going to need to have another mesh in here. All right, so if I pop on back over into here, we can go ahead and set up a second mesh that we'll want to stream or want to have in our setup. I think that maybe for now we can just use a window mesh. Why not? We've already got it made. We'll go ahead and have two of these debris fillers, and the other one will be for the window mesh. Now, the problem with the window mesh is that it's huge in comparison. The mesh for the windows is like 3 or 4 times larger. In fact, this is already scaled down to 0.5. So we're going to have to put in a scaling capability here. Public float min scale equals 1 and public float max scale equals 1. Here what we'll do is we'll set the local scale equal to a value between those. So float scale equals random.range min scale comma max scale. And what we're going to need to do is actually only do that if they are different. So float.scale equals min scale. If min scale does not equal max scale, then scale equals this. And then what we'll do is we'll say that your transform.local scale equals scale times vector 3.1. That way we'll be able to set the scaling to an arbitrary set of sizes, which is going to be nice. So we'll go down to our debris fillers and set this up so that it feels good. Right now we are scaling these to 0.2 using the prefab's built-in scaling. See this? That's going to get overridden, so we're going to need to make it a min scale of 2 and a max scale of maybe 5. Over here on the second one, we're going to need to scale these windows down, so maybe like this. Let's give it a shot. It sure takes a long time to spawn all these game objects in, which is why I'm going to have to convert this over into either a particle system or a set of prefabs that I generate at edit time. Both of them have their advantages. The other way, which uses raycasts, I do it only during edit time just because it's so expensive to do it during runtime. So it's obvious this is getting the same way, so I won't be able to do this just willy-nilly. You can see the debris here. It's starting to feel pretty decent. Got lots of floating elements. Spherical shape really isn't doing us any favors though, because the interior of this space isn't spherical. It's just not. So what we're going to do is we're going to modify this to do raycasts and to do it not during start, I think. So what we'll do is we will set this up as a non-start. It'll be void seed or void plant. And we'll do menu item. Start, go, what is, okay, hold on. I have another one. We'll use the same plant debris. Yeah, this. There we are. And then again, we're going to want the same setup for unplanting it because deleting 1,000 objects is obnoxious. There we go. So this is the same thing that we do already, but now what we're going to do is we're going to raycast out from the center of the sphere towards the position instead of whatever we were doing. And we will go ahead and set that up. So rather than this pause being inside a unit sphere, it's going to be on a unit sphere. That'll make it a normal. And then what we'll do is we'll do a raycast hit out here, and we will do if physics.raycast. We don't have a ray set up, so we'll have to specify it here. Our ray will be the origin transform.position and the direction of pause. Yeah, that's fine. And then we'll want to have a max range of radius and an out hit for our hit values, right? Yep. Good. So if we find a raycast that we like, then what we're going to want to have is a range. So we'll do float range equals 0 for this, just to get range tested. We will go ahead and say that the range equals hit dot point minus transform.position. That'll be the range from the center of our sphere to wherever we impacted. So that'll be the total amount of space that we can fill with debris in that direction. And then what we'll do is we'll make this equal to radius. So down here what'll happen is if we didn't hit anything, it'll be up to the radius. Otherwise it will be somewhere between 0 and the position that it hits. So then we'll say range times equals mathf dot square root random dot value. And that'll give us a value between 0 and 1, weighted more towards 1, meaning that we'll have more debris towards either the impact point or the perimeter of the sphere. And that'll be good. So then what we'll do down here is we'll set the scale, sure, why not, but we're going to want to have this get set up here. So our position is going to have to be range times pause. And pause is a normalized direction, so that should work fine. Oh, I forgot to actually run it, which is fine because I actually broke it. Cannot convert from vector 3 to float. Range equals hit.point minus transform.position. .range, magnitude. There we are. Perfect. Now that I'm thinking about it, though, I might be able to turn this in... Well, okay, there's no reason to optimize it any further than that. I have an optimization I could make, but I don't really want to make it. All right, so we're going to grab this debris filler, and we're going to tell it to start up its debris engine. We're going to give it a radius of 250, I guess, and plant debris. Okay, so you can see how fast that was. You can't tell how fast that's going to be in the game, though. So here, you can see we've got a massive amount of debris where the spots are closer together. If I were going to move that center of that sphere around, we could change where that density of debris is. Alternately, rather than having it be a sphere, we could make it any sort of other shape. For now, however, I'm going to go ahead and clear out the debris and move it a little bit out into the open mouth of this shape, and then plant the debris again. That way we'll have debris that's mostly clustered in this open mouth, and that would make some sense. The other debris element that we have, this guy here, is still over here in the corner. We'll go ahead and move it into the mouth as well, and then tell it to also plant debris. And there we go. We now have a ton of small windows. It's become clear that those windows are much too small, so we're going to clear those debris and change this to a 0.5 to 1, and then plant the debris again. I think they're still too small. I thought they were much larger than that. I guess not. So we'll clear that debris again and change it to 1 to 2. That's probably right. They're still kind of small, but whatever. We'll go ahead and just see how that looks. Now, doing those actually requires you to do, 1,500 raycasts, which is not cheap, which is why I'm not planning on ever doing it in play mode, only in edit mode. But it has the advantage of I can tweak it as well if I decide that I'd like it to be different. It's pretty easy for me to change it. Still running at 70 plus frames per second. Good, good. Let's put the brakes on here. This is pretty trippy, man. Look at this. This is super creepy. I love it. Now these windows have two materials, one of which does not properly get shadowed. As you can see, the glass doesn't have the right shadow textures on it. The result is that it literally glows in the dark. To be honest, I think that might be the secret of making a really good set of interior debris. Let's go ahead and test out my theory. What we'll do is we'll change that desk a little bit. This desk has two materials on it, as you can see. I'm going to go ahead and change that out a little bit because I don't want them to be quite as common as they currently are. So we're going to just go ahead and select all of this stuff and set it all to hull. And then what we'll do is we'll make certain elements of it glow in the dark by using the interior, but it's not going to be the interior. It's going to be something that glows in the dark, which at the moment is glass. So now we've got a couple of things that glow in the dark, and I think we're going to go ahead and set it up. Do I want it to be an edge or a leg? I think that an edge would look better than a leg. Boom. So now we're going to save that, pop back over into Unity, and we're going to want to change that prefab to have that glass element instead of Prox Interior. We're going to go for glass, particle glass. No, this is particle solid. This is particle glass. And then we will go ahead and see whether that properly updates. Did that properly update? No, it didn't, because these are all considered clones, not linked to the prefab. Okay, so we're going to need to clear those all out and do it again. No biggie. So clear and plant. There we are. Now we've got some glass. It's backwards. All right, so clear. And we'll go back over and we will swap the two between the slots that they're in, because obviously I've got them backwards. So this one will be particle debris glass, and this one will be solid hull. I'm not sure if I want it to be solid hull. I think it might be better off as Prox Interior. And the reason for that is because Prox Interior is dark at range, meaning that it won't glitter. And I don't need it to glitter. Not at past 200 meters. It would be really distracting. Plant debris. Let's go ahead and try it out now. Grind, grind, grind. I should probably move this to be closer to my spawn point. All right, look at that glitter. I don't know, but that already says debris to me. Doesn't it? Doesn't it feel like debris to you? I feel like this might be a winner. I feel like this might turn out really well. But the real question is, how does it look in the dark? So we'll just plunge through into the shadows. Oh, this is so cool. Can you believe we're running at 70 frames a second, guys? This is just nuts. In fact, it's so nuts, I'm going to take a screenshot of it and upload it to Twitter, I guess. Come on. There we are. Oh, ho. Ho, I think this is a winner. Indie dev, and paste in that picture. Now the best thing about this is that we can LOD it away. We can just get rid of it if you're at a certain range away, and that makes it quite nice. Albuechi says it's a little bit awkward because you push things away like you have the force. Yeah, that's actually something I can adjust. So let's go and adjust it. Basically, the problem is that in the cheap version of the pushing that I'm using an object on the ship as a pusher. And the object on the ship is just scaled kind of randomly. So I can easily reduce the scale quite substantially. Previously, I was pushing very large things, and I was using only the center point of the target as a collision point. I'm still doing that, but now the objects are quite small, so it should be okay. Hey, Cody. We're working on debris. 90 frames a second with this mess? Are you kidding? This is amazing, guys. This is incredible. Oh, that felt really good, guys. I think this is going to go well. I think this is seriously a winner. These shapes are not a winner. I have to change these shapes, but this idea is looking really, really good. Oh my gosh. Oh my gosh, that feels great. Oh, this is nuts. I can't even tell whether you guys can even feel what I'm feeling since I'm the one in control. And it's one of those things that I'm not sure actually gets communicated just by a visual and a couple of clanking sounds in the background. Obviously, there's a lot of polishing that needs to be done, but this ability to just like plow through a field of tangled debris is super cool. Like, holy cow, it's awesome. I could even add in like effects that make your ship jump. You know, like when you hit it, it vibrates your ship or something. I'm not sure I want to make it actually change your velocity, though. I think that it's probably better if it doesn't actually change your velocity at all. Cody says it looks like something massive and something big exploded here. You know, Cody, it's astonishing, but you have just now explained exactly what my game is about. If you take a look, what do you think exploded here? I'll give you a hint. It was something massive and something big. This is a game about salvaging from huge space wrecks. So it's supposed to feel really cool like that. And you nailed it. That's exactly what it's supposed to feel like. Cody says it looks great. Sounds good to me. Let's do one more pass through the debris. This time we'll go at full speed and just see what it's like. I didn't even hit very many of them that time. Neat. Okay, so there's a couple more things that I want to test with this system. Right now what I'm doing is I'm creating a system that doesn't have any serious LOD elements to it. It just creates a spew of objects. What I'm gonna do is create an LOD system for it. Now the way I'm gonna do that is I'm gonna have it fill itself with 2 or 3, no, 2 is fine, two distinct sub-objects. So we're going to clear out the debris here, and we're going to add in two new sub-objects, which we will call LOD0 and LOD1. Now the problem is I'm not actually sure whether or not I can get the LOD management system to run with this, because it's renderers, and it doesn't. I don't want to specify renderers. I want to specify sub-objects, and I don't think I can do that. So I may have to program my own LOD system for this, which isn't a catastrophe, but it's also not great. So we're going to go ahead and pop into here, and we're going to go ahead and put in a transform set for our LODs. Public list transform LODs. And here we're going to go ahead and put up a tooltip. Lower equals more detail. Just in case I forget which direction LODs work. So what we're going to do is during our update phase, void update, we're going to test how far away we are from the camera and maybe whether we're in view. I'm not sure yet. But basically, we're going to go ahead and have a test based on how close we are to the camera, and we're going to turn things on and off based on that. So vector3 range to camera. We're going to need to cache our camera. So new camera. And in here we'll say if camera equals null, then camera equals camera.main. This is an expensive call, so we'd cache it. We only do it once. If we change main cameras later, we will regret it, but whatever, right? So the range to camera will be camera dot position dot transform dot position. We could do this more complicatedly by taking into account the actual view of the camera, but I don't feel like it. We'll just do it nice and dirty. There we go. And so that's going to be how far away we are from the camera. And basically, we're going to want to know how many multiples of our range that is. So float range equals, we'll take our radius. So range to camera divided by radius. And if range, so hold on, we actually have to cache public int current LOD equals 0. So we're going to want to figure out what LOD we actually are and that sort of detail. So hold on. I think that's something where we're going to want to do it a little bit more interestingly. Int LOD equals 0. And then current LOD will be a getter and a setter. So get return LOD and set. So when we set it, what we're going to want to do is turn on all of the transforms that are above or at that level and turn off all of the ones that are below it. So for int a equals 0, a is less than value, a plus plus, and then we say LODs a dot set active. Okay, I have to do game object. Game object dot set active. If I have to do that, I might as well make these into game objects, so I don't have to do the set active false. And then what we're going to want to do is for int a equals value, a is less than LODs dot count, a plus plus, LODs a dot set active, true. Perfect, right? So what that'll do is that'll actually fill up our levels of details. As we get closer, it'll turn them on. This is slightly different from a normal level of detail group because it leaves all of the low level of detail on. So as we get closer, we don't turn off the low level of detail. We just turn on more detail. And that's important because we're using a particle-based system. So basically, the closer we get, we don't need to lose that outer shell of particles. We want to just turn on more particles. And so what we're going to do is we're going to have to set this range up to be an LOD level. So if range is less than 3, then we'll be a full LOD. If range is less than 3 and LOD does not equal 3, LOD equals 3. Up here, why is LOD blue? I'm not sure I like that. Oh, because current LOD is what I need to say. There we are. I actually forgot to make this work. We have to say LOD equals value. There we are. That'll work. And we can also up here say if LOD equals value, then return. Otherwise, we'll end up doing too much work. So we'll just go ahead and rely on that. Boom. Current LOD equals 0. Else, if range is less than, say, 6, current LOD equals 1. Else, current LOD equals 2. There we go. So to entry 3 is always on. There we go. We can always change that later if we need to, but that's the basic idea. I don't think that this number is correct. We're going to change it to 10. Yeah, there we go. The question is, what are we going to do up here? Because we need to actually add these to specific sub-objects rather than ourselves. And moreover, here in uproot, we actually need to do this to each of our LODs instead. So for each game object LOD in LODs, while LOD.transform.childCount, then LOD.transform.childCount. That will be a little bit more specific. That's good. And here, instead of adding these to an arbitrary set, we need to add them to a level of detail. And we're going to do that based on their range. So float % equals range divided by max range radius. If % is greater than 0.8, 0.9f, then we will add it to, well, we might not have 3 LODs. We might only have a couple. So let's go ahead and do this simple here. Int LOD equals % divided by LODs.count. And that way what we'll do is we'll end up with an integer value that could be 0. If, say, you're at %.3 and you got 2 LODs, it will end up rounding down to 0, right? Yeah. And it should never be higher than the counter. I think that I'm doing this wrong. Do I want to multiply it instead of divide it? I think I want to multiply it instead of divide it. Do I? Yeah, because %'s always going to be between 0 and 1. Yeah, okay. That should be correct, right? Right, good. Later on we can do something else like change it so that it's not square rooted or something, but for now that should work. And then here what we'll do is we will say LODs LOD.transform. I'll call this something else like LOD index. Taking off my headset because it's getting really obnoxious. LOD index. There we go. That was a lot of grinding. We've got some errors. We'll fix them up. Oh man, it feels really strange, like I'm deaf in one ear after wearing that headset half on for so long. Just cast it to int. That should use a floor. Cannot convert to float. Range equals range to camera dot divided by radius. Range to camera dot magnitude divided by radius. I guess I did not need any parentheses around that, to be honest. Doop, doop. There you go. Good. Perfect. All right. So now what we're going to do is set this up to actually have the values that we need. So we're going to delete this one because it's now structured completely incorrectly. And then we'll put in LO space Ds. I'm not sure why there's a space there. I got them backwards. Try that again. LOD0 and LOD1. Yeah, that's fine. And then what we're going to want to do is populate them. Let's try it out. Plant debris. So we've just planted a lot of debris, and you can see that what we've got is a lot are in LOD1, and very few are in LOD0. And the reason for that is because we are weighted, I guess there's a lot in both, but we're weighted towards that outer ring, which basically means that we end up with a lot of extra notes in that outer ring. So what we're going to want to do is, rather than just using pure percentage, we're going to want to do, we're going to want to actually have that before we square it. So float percent equals random.value, right? And then here what we do is we say percent, and then down here we say percent divided by radius. So percent divided by equals radius. No, wait, you just use a percent straight up. Great. So that will actually break us up into a more even set of bands. Yeah. Yeah, good. Right? I didn't make any dumb mistakes there. Clear debris. Plant debris. So now if we look at LOD1, it's the outer layer, and LOD0 is the much more numerous inner layer, and that's what we're looking to do. So we'll duplicate this and have it set up to do the other prefab, which is the window pane. Boom. And we'll go ahead and tell it to clear itself out and then spawn itself in. And let's go ahead and see whether or not this works. So what we should see is that LOD0 should be on and LOD1 should turn itself off. Got a long startup time today. Yep, so there. You can see that LOD0 is off and LOD1 is on because I got them backwards and I'm a big dummy. Does that mean that the exterior is off, or did I just get the whole thing backwards? Because I've got the whole thing backwards, and who gives a shit? Oh, see? See how that popped into existence? So that's the basic idea. I think that we need to turn up some of these values. And while I've got this correctly set up, it actually doesn't use the same naming convention that you're supposed to. Because normally what you do is you actually, 0 is more, how does this, what, do I have it? LOD0. So if it's at LOD1, then of course LOD0 would be off. I've got this correct. Don't I? LOD0 should be off. Is LOD0 off or is LOD1 off? It's just a naming convention thing. Come on, finish loading. I don't know why. I guess it has to do something with all these thousands of game objects I've spawned in. LOD0 is off. Good. That is correct. Excellent. So we're going to change some of these values. I think that 3 is probably wrong. We'll go ahead and make this 5, and we'll go ahead and make this 15. Perfect. A couple of them snuck through in places where I can't, I didn't set up a collider. So I've got a couple of them that are floating in deep space. So you can see that we can see the outer shell and then it pops into existence. The problem with that, of course, is that that pop-in is pretty egregious. We'll have to tweak that some and figure out exactly what we want. But what we should be doing is placing it so that the outer shell is visible from the outside, but the inner shell really isn't. We'll have to work on that. Look at this. Look at this ball of desks. All right, I'm going to go ahead and take some screenshots. Um, I'm not done yet, but I am working on the final stretch here. Let's go ahead and take a look from outside. Yoink. Ah, bunk. Bunked into something, of course. Exciting. Okay, so I don't think that I got very many viewers with that, but I think that I'll get a lot of players with it. The problem is that this startup speed is getting really slow, which I think is probably because it's trying to turn everything on. If I start these as turned off, I wonder whether or not that will load faster. No, it doesn't really seem to. Well, that load up time is going to be a real pain in the ass. If these are turned into particle systems, that might negate the load-in time. We'll have to try it out. Crash. So the other thing I want to do is test that same technique in another piece of debris. Because I have several different kinds of debris, and I want to make sure that this technique can work for other things. The interior spaces are only one part of the puzzle. There are also plenty of exterior spaces, such as this ripped up engine. So what I'm going to do is I'm going to go ahead and set up this ripped up engine with some colliders. We got mesh collider, convex, mesh collider, convex. Go ahead and inflate that one. There we are. And then here, this one, unfortunately, we can't set it up as a convex mesh collider, just because it's not convex. Later on, I'll have to replace this with a set of meshes so that we don't have such a complex collider, because this is going to be a really expensive collider. So we'll have to live with that. We could make it convex, but then we wouldn't be able to fly through it. You can see how that would be a little bit obnoxious. Anyway, what we're going to need to do is take a duplicate of one of these debris fillers and drop it into our engine. There we are. Hello? There we are. And just go ahead and move it to the middle here. And then what we'll do is we will put it over into the area, which has a lot of random debris. And we'll set this up to just use a debris object instead of the furniture, because the furniture is not quite suitable for this. There we are, like that. And then we will tell it to clear itself out. And I'm going to turn these on because turning them off doesn't seem to help any. Clear debris, and then plant debris. All right, so you can see what happened here is we got a sphere of debris. Although this sphere is supposed to be heavily weighted towards the outside, it didn't seem to actually get weighted towards the outside. So here, float percent equals random.value. That's a 0 between 0 and 1. Then what we do is we take a square root of that percentage, which should drive it towards 1, like a lot. Another thing we could do is we could do 1 minus percent times percent, but that should be the same thing, right? Well, we'll go ahead and try it out. So once again, clear. Oh, I guess it's gotta wait until it's re-imported and then paste. Yeah, so you can see that's not really... It's not really very strongly weighted towards the shell. It must be just how this works. But you can see that it's definitely clustered in the middle, which is strange. So what could be causing that? Get the position at the range, a unit square. Range equals radius. Range equals hit.point minus transform.position.magnitude. Is there like a hit.range distance? Yeah. Yeah, so we'll just use the hit.distance. But that shouldn't change anything. Because it's just not going to. We're going to use percent times percent times percent, but I think that at some point it becomes ridiculous and stops making sense. It could also be that the reason those things are at the center is because there's colliders there. You know, obviously there might be something like that. Let's go ahead and just try this. You know, I guess this is probably correct because it's filling so much more space when it moves towards the outside. But basically what I want to see is I want to see it clustered in this area, but it's not. There's not really a sense of heavy debris here, which is odd. I thought that it would be. Let's go ahead and move it closer. Oh, come on. All right, so let's see whether that will work. Clear the debris and plant the debris. Okay, so that creates a cluster, all right. It's not really... I might need a new kind of planter to plant a debris that makes sense for this. I'll need like a linear planter. I do have like a surface planter where it would broadcast down and just flatten everything against the surface, but I don't think that's what I want here. Anyhow, I'll deal with that some other time. For now, I'm pretty happy at the progress we've made. It seems to be pretty fun. The slowness of it is all in the loading time. And I think what I can do is change it so that that is turn it into a particle system ahead of time rather than using this. Now, the advantage of a particle system is that it doesn't actually have game objects for every particle. And that's super nice because game objects for every particle is a real pain in the ass. And what that would mean is that I would probably do particle systems nested inside of this object, with each particle system being a level of detail. And then what I would do is I would turn on the particle systems as you approached. And how many particle systems, how many level of detail, would depend on how dense the field is, because a particle system caps out at about 500,000 verts. So it's just a restriction, I guess, on the number of verts it's willing to pump. The problem is I'm not at all sure that the particle system is fast. I think the particle system might use dynamic batching instead of GPU instancing. And if that's the case, then we'll lose a lot of speed. Like, we'll drop down to 30 frames a second. And that's not great. Anyway, the other thing that I still need to do is I need to set these things up so that they are convincing as objects. So we'll just drop these debris in there and turn them off temporarily, because the interior is still not very convincing. Now, the real problem is these edges are really pretty bad. What I've done down here is I've put a couple of edge-like objects in. You can see that there. It's not a great solution, but it's certainly better than not having any. So we'll go ahead and try some edge-like objects up here and just see whether or not we can create a convincing edge. Because I think that what I'll eventually need to do is have these edge-like objects and that structural fill that I created at the beginning of the episode. But you can see the problem here is that if I don't fill all the way up to here, then it looks weird because there's a weird crisp edge. But if I do fill all the way up to there, then I've got an edge on the other side, see? So that makes it so that this has to be a protruding edge, like an edge that is upwards. And that is not really what I normally want. The good news is that is what I want here, so I might as well go ahead and do exactly that. And these are basically free. I can use as many as I'd like. It's a matter of making them look decent rather than keeping them to a minimum. So that's decent, right? It's a good optimization if you can get things for free. Of course, right now I've got this blue element, which doesn't convincingly merge with this plate that I'm creating. So I'm going to just move the plate around until the blue element feels like it's not so bad. And then we'll just continue on our way. I'm sure there's a way to do this automatically, but for the life of me, I can't think of an algorithm that would work reasonably well. If you happen to know of one, let me know. Otherwise, I'll just have to do it by hand. It's not a big deal. To get the kind of performance I'm getting, I'm happy to do shit by hand for a while. But obviously, it's a bit of a concern if I want to generate a lot of different variants, because doing a lot of different variants by hand would be a pain in the butt. I think that I can go ahead and get away with a lot more aggressive work on this one. Like, yeah, like that. I think it's a little too vertical. Let's bring it down. I think that's okay, for starters at least. What is this bulb? Oh, it's part of the core object. All right. What happened? Why did it freeze? What's happening? Please don't crash now? I would be annoyed. I don't know why Control-Z would make that crash. All right, well, I guess I'll check my Twitter while I wait. Unsurprisingly, nobody said anything. Oh my god, is this seriously gonna... Oh, that was so fucking weird. Let's go ahead and save. I agree, there is a lot of stuff to serialize Unity. I understand why that would be a concern for you. In the long run, this will be turned into a prefab that I can just plonk down. And in the short run, however, it's clearly not the case. Problem is, it's got 34,000 objects. That's a lot of objects. Wow. I can see why Control-Zing took so long, because this is a nightmare. It might actually be faster to do this live, now that I'm thinking about it, the particle generation, because the particle generation is really, really... let's clear the debris out of these, and then save again, just to see. Yeah, it's just these guys. These guys are the only thing that's really slowing everything down. So we're going to go ahead and create a variant that just allows us to do this. So public bool plant on start equals false equals true. There we are. And we'll go ahead and put in a start menu, void start, if plant on start, plant. All right, so now what we still need to do is to grab the structural elements that I created. There you guys are, and put them on this side. Now the problem is I can't friggin' see because the shadows are too dark. I think what I'm gonna do at the moment is turn off lighting. That froze it. Okay, there we are. So if I turn off lighting, I can get a sense for where everything is, and that's important for the sake of actually having stuff work. What's with this slowdown? That was weird. Give me a copy of this. What the hell? Where? Okay. Whatever. So basically what I'm doing is I'm using these structural elements to fill in underneath the plane elements that I have. So what's going on here? Why is it so slow? I might need to reboot Unity because this is behaving quite strangely. But what I was trying to say is I'm basically using these to back the oh, I bet it's the undo queue. I bet the undo queue is just full of megabytes and megabytes of crap. That's fine though. I'm using these to back these elements that I've used to make the edges rough. And by putting these up against those rough edges, the theory is that it'll be a relatively convincing set of hull damage rather than just being an edge. That's the idea. I'm not 100% sure. Now, I could partially automate this, but the problem is that this element here that I'm maneuvering now is not always going to be oriented the same relative to the surface object. Instead, the surface object can be spun in a lot of different configurations, and then this would need to be mounted underneath it relative to the rest of the ship. Okay, so this is going really slowly, and I think it's because of the undo queue. So what we're going to do is save the game and then reopen it, because that'll clear the undo queue. Nope, it's running like crap just in general. All right, we're going to reboot Unity. So let's go ahead and close you down. And then we'll bring Unity back on. Lots and lots of grinding. I guess I'll take this opportunity to delete the streaming video from YouTube since I'm going to be done streaming soonish. Grind, grind, grind. Are you serious? You haven't even gotten to the boot screen? Jesus, took forever. I think there might be something screwy going on here. I'm not sure what it is. Yeah, look at that. There's still something wrong. What could it be? I don't have any more ultra high poly objects or ultra high density objects. What I'm going to do here, I'm going to go ahead and grab this shell. I'm going to copy it. We're going to go over to a new scene. Paste it into the new scene. That didn't seem to work, did it? Paste. Hello? Okay, there's no reason it should take this long to paste. It's not a complicated object anymore. I took out the 11,000 objects that were in it, and now it's just like 50? Come on, why are you being such a dork? Maybe I have to reboot my machine. It has been up for a while without a reboot. But I haven't noticed any slowdown, except for here in Blender. I was using some Marvelous Designer 7. Maybe that has a memory leak that I'm not aware of. All right, so if I take a look here, the number of objects in the call ship here is not very large, as you can see. There is something to be said for exactly how large you need to make things and the exact order in which you should make things, but now it's running fine. I'm not sure what the deal was. I'm going to have to probably figure that out in the long run, but for now, we're just going to go ahead and set up these objects, and then I can always paste it back into the other game environment. Oh, hold on. Now it's running slow. Is it because of the colliders? They shouldn't be caring, should they? This is strange. I can't do any more work. This is it. It's too slow for me to deal with. I'll try and figure out why it's so slow, and I'll come back to you on Sunday after my region's famous music festival. So I might be slightly deaf. Thanks for stopping by, and if you have any suggestions or comments, feel free to leave them, even if you're watching this on YouTube or after the fact in some manner. I'll see you on Sunday. Now, where is the stop button?